Alright, hey guys. So I figured I would do a quick video going over the review packet that you guys got in class. I know the test is coming up very soon, so it's a good idea to kind of watch this video either all the way through so that you get a good feel for all of the different types of things you could see on the test. Again, this review packet is based on the test, so if you see a section that says expand the expression, you can pretty much be guaranteed that there will be a section on the test that says expand the expression. So when you're watching this video, if there's ever a point at which you feel like you're really an expert on expanding expressions, you are more than welcome to jump to the sections that you need a little help with. Again, this video is for you. But again, I will not be hitting every single question in this packet. So please make sure you refer to the answer key also posted on Canvas and check the answers that we don't go over in this video. So in this first section, you have expanding the expression. The log one, some people feel a little uncomfortable with the ln one because they're like, oh, what is this ln? But actually this log one's going to be a little bit harder because it has a multiplication and division going on, where the ln just has multiplication and an exponent. So we kind of have time for both, so I'll see how much we get through. But if we look at the log one, it's kind of best to think of it like this. You have your top section, which will become the log of 3x, and then you are dividing that by the log of 2y. So division, of course, becomes subtraction. I apologize that the video is a little grainy. Hopefully you can read this. Once you do this, a lot of people have stopped at this point and said, okay, I'm all done. However, there is still multiplication going on in both of these pieces. So it's kind of important to think back and say, okay, I have the log of 3 being multiplied by x, so that becomes plus the log of x. That is kind of my first piece, so it's nice to kind of group those together. I still have that subtraction sign of the bottom piece, so that will become the log of 2 plus the log of y, because again, that is multiplication. The second piece, like I said, it's ln, but if you guys recall, ln is still log. It's going to be the log of base e, and then, some number equals some other number along that lines. It's still a log, and therefore all of these properties that we just talked about over here still apply. So when you split this up, you're going to get that log of 3 plus that ln of y to the 4th. And then if you recall, our third property was talking about these exponents. So these exponents kind of come forward to the front. And so what you're really going to get your final answer to be is ln of 3 plus 4 ln of y. The exponent kind of goes away. Good rule of thumb, especially when we go into the condensing thing, is to definitely make sure that you know the 3 properties. Those 3 properties are going to be, if it's addition, you turn it into multiplication. If it is subtraction, you turn it into division. And then, of course, if you have an exponent, say 4, as long as it is a log problem, this right now is not a log problem, so there's really nothing I can do with that. But if I throw a log or even an ln in front of that, then it becomes a log property, in which case I can go ahead and move that out front. Those are the 3 strong properties that you definitely want to have a good grasp on, especially when you're looking at condensing. So when we look at that first problem, I would highly recommend starting with saying, what are these numbers out in front? Really? These numbers out in front are actually going to be my exponents. So I'm going to get it in x to the 3rd, and then over here, that's going to become a y to the 4th. I mentioned in class at any time that you are condensing to make sure that you only have one log. So it's nice to kind of go out front, write that log of 2, and just be done with it. Don't touch it. Don't try to divide it by anything. Don't do anything else to it. After you have that written, you can go ahead and say I have a 7. It has a plus sign, so that means I'm turning it into multiplication of this now x to the 3rd. And then I have subtraction of this next piece, which means I am dividing by y to the 4th. And then I am done with that problem. It's completely simplified. I know that problem number 4, when you simplify this, you're going to make that your exponent. You really will get an ln of 24x. divided by 8. The 24 and the 8 are allowed to be simplified. So you can go ahead and turn that into the ln. 24 divided by 8 gives you 3x, and that would be your final answer for that one. The next section is evaluating. A lot of different things going on in each example. They each have their own purpose. None of them are really repeats of the previous skill. So when you're looking at number 1, that would have been something we did during those warm-ups with the slides. So you would kind of set it equal to x, rewrite it given that formula. If you don't have that formula down, I'd highly recommend that when you get your test, quickly write it on the top of your paper so you don't forget it. And here's what I would write down. I would say that if you have log of a small little b, and it doesn't really matter which variables you pick, let's say that we go with y equals x. When you convert that to exponential, it's going to become big B to the x power equals y. So the x and the y really switch sides every single time. So when I'm looking at number 1 and I now have it set equal to x, if I write that in exponential form, my base, which is now 4, will always remain 4. It's just a matter of the x and the 256 switching sides. So the x is going to come over here, the 256 is going to come on the other side, and then it's just a matter of solving what x could be. You're going to do the same thing in number 2 and number 3. Again, just setting those equal to x, doing this conversion right here, and then solving for your variable. Now, number 19 and 20 are ln ones. So it is important to remember 2 rules about ln. If you have ln, let's say, of y equals x, when you convert that, that will become an e to the x power equals y. So similar property that happened up here, the x power equals y. It's just since we don't really know what the base is, well, actually we do know what the base is, we just don't see the base. We assume that since it's an ln, that base is always going to be e no matter what. Also, an important rule of thumb, if you wanted to write this on the top of your paper as well when it comes to test day, is that if you have ln of e, we always know it to be 1. So if I'm looking at this problem up here, I can go ahead and set this equal to x if I have a burning desire. It does have an exponent, and according to the rules up here, if it has an exponent, I can go ahead and move it out front. So this is going to become -4 ln of e. I see this ln of e, super important. I know that it's really just going to become 1. And therefore, I have my final answer to just be x equals -4, done. Now, number 19 is one you could type into your calculator if you wanted to. Again, it'll spit out your answer, no problem. However, if you wanted to try to use this conversion factor down here, up here, then you look at this ln and you say, okay, if I turn this into an e, that's going to become e to the x power equals 1. Well, anything to the 0 power gives you 1. No, that's a given rule. Anything to 0 power is 1. So if this equals 1, you can pretty much assume that x is going to be 0. And if you don't trust yourself, the calculator. Again, at this point, we are 8 minutes in, and we're barely through the first page. So if you understand all of this, jump to the stuff that you need help on. Down below is the converting it to exponential and logarithmic form. For some of you, all you're really going to need to review are these rules right here. These are the ones that I would write on the top of my paper when I got my test. I'd dive right into it so that I knew that I had that. Maybe even these rules, up here that we talked about, the different power rules. If you know those 2 sections, you will ace the test with a little bit of graphing help. But that section is a big portion of the test. So using those rules, we can kind of look at some examples down here. The first one, again, assuming you know these boxes, it should be a really quick thing. You get 2 to the 6 power equals 64, done. No work has to be done. ln of e, again, you can kind of look at this conversion factor up here and say that it will become an e And then you'll also see that the opposite side became my exponent, so that means I'm going to have an exponent of 3 equals 20.09, done. Down below, turning it to logarithmic form, number 7 is one where you'd say, okay, let me make this log base 2 of 32 equals 5. Again, your base of your exponent becomes the base of your log, and then the 32 and the 5 just kind of switch sides. Number 8 is one that I've been getting a lot of questions on. It seems like it's already in logarithmic form because it has that ln, and that is a true statement. However, if they wanted it with a log, then you would just, instead of having ln, have log of little e, because that's what ln really stands for. Then you have your big E from the original with an exponent of 4. Now that it's in logarithmic form, although it was also in logarithmic form up here, you can go ahead and pull that 4 out in front. And what you'll get is that 4, let's stick with the ln, we'll have ln of e. We know that ln of e is just going to go away and become 1. And so my final answer for this one is going to be 4. So this isn't really one that you would have to see on your test as far as writing it in logarithmic form. But it is nice to know that you could pull that 4 out in front and ln of e is just going to go away. This one will simplify to just 4. Going ahead on the back side now. The back side is the graphing portion. Both of these two problems have their own special properties, you could say. So the first one actually has an a value. Here's my a, here's my b. A tells me where I should be starting my graph. So I should be starting my graph at y equals -2. And then I have to think about my translations, which says -4. This is in the exponent, which means I should do the opposite of it. Just like when we talked about having it inside the radical, you should do the opposite of it. For this one, I have it in the exponent, so I want to do the opposite of it. So if it's a -4, I'm actually going to go +4. It is with the x, which means I'm moving in the x direction. So I'm going +4, 1, 2, 3, 4. This is the dot that I'm going to be using for my graph. And then all I do is look at the b and say that this is going to be decay because it is less than 1. And this is going to work out to be 0.3 repeating, which is pretty far away from 1, which means I want it to be fairly steep. So as I read it left to right, my graph needs to be going down. So I'm going to go ahead. You can kind of start it anywhere you want. You want to start it over here. You want to start over here. That kind of just depends on how steep you want it to be. But you should know that the second you hit the dot, you should consider yourself leveling out. Okay. The next one, there is no a value, so we know that a is going to be 1. So that means I'm starting my graph at this y equals 1. And then it's just a matter of saying, where am I moving from there? I am going +3. So again, that's in the exponent, so I'm going back 3. It's a -3 on the end, so I'm going 1, 2, 3 down. Here's where my graph is going to go ahead through. My b value up here tells me that it's going to be growth. It is kind of close to 1, 100 would be very far away from 1. This is pretty close to 1, so it could be on the flatter side, but not completely flat because, again, it's still kind of far away from 1. So if I do something, whoops, switch that up. This is growth. That's why you wouldn't want to go that way. So growth would be, as I read it left to right, you do want to be increasing. And then, of course, on this side, kind of leveling out. All right? So be careful with the growth and the decay. Sometimes you can see you get carried away with that. Number 11 is one of those ones that you can kind of pick any values that you want as far as x and y goes. When you're picking some values, if you pick numbers that are too big and you start getting crazy numbers, you're of course going to want to try some different numbers. So if I picked, like, let's say 100, 99, 98, 97, 93, those are huge numbers. First of all, they wouldn't really even fit on my graph. And second of all, when I start plugging them in as exponents, it's going to get outrageously big. So if we pick some reasonable numbers, let's say -2, -1, 0, and 1, 2, those are kind of my go-to numbers. Odds are you're going to be pretty reasonable within there. You will get that about 0.2 repeating, 0.6 repeating, 2, 6, and 18. 18 is kind of high, that will be off my graph, but at least all my other ones will be in. 4 is kind of all you need on your graph, but you do want 5 in your table, at least 5 in your table. But if you only can graph 4, that's okay. So if I go ahead and graph this, I'm going to have that -2 and 0.2, -1, 6, 0, 2, 1, and 6, and then of course that 2 and 18 will be off. And then it's just a matter of connecting these dots. Now, a couple people have been coming up to me in class and asking about asymptotes. The asymptotes are basically that imaginary line that you can't cross. And if you recall me saying in class, anytime you have a standard graph, this is a standard graph because there is no translations, there's no pluses, no minuses. Anytime you have a standard graph, your asymptote is going to be the x-axis. So if you wanted to label that, you could kind of say, you know, here's my asymptote. Or you could say that it's going to be the y=0 line. Or you could say that it's the x-axis, however you want to do it. As far as these graphs go up here, it starts out when my standard graph is right, where are we? So we're at -2. That means that my asymptote is going to be right along here. Okay. And then once I have that filled in, I can go ahead and say, okay, it moved over. That means my asymptote's not going to change. Moving left and right doesn't affect that. Up and down, however, does. So when I'm looking here, here's my parent graph. Here's where I would have started. Here's my original asymptote right around this area. I went down 3, so is my asymptote. It's going to go 1, 2, 3. Here's my asymptote. Okay. It is an imaginary line, so you would probably want to put it in dashed or just label it. But for the purpose of this video, I want you to be able to see it. So your graph should not be going past this. A couple people on their quizzes, their graphing ones, I saw them go, woo, and get a little carried away. That's unreasonable. It should not be going down that far. The second it hits that dot, it should be leveling out. Or, you know, over here, it hits that dot and starts leveling out. So that's kind of the purpose of the asymptote, is to make sure that you're not being a little unreasonable and taking it all the way down here, but instead taking it and just kind of leveling it out. So when in doubt, once you hit that dot, start leveling it out and you'll be safe. But otherwise, that's kind of where the asymptote is. It's usually going to be the x-axis anytime that you have an untranslated graph. All right, moving down to the next section is the change of base section. The change of base, if you notice on the front page, we go back to the front page for a second, this one specifically said, do not use the change of base formula. Because given a problem like this, we could have done the change of base formula and got log of 256 divided by log of 4. Type that into our calculator and it would have given me an answer, which, you know, would have been absolutely correct. However, since it says do not use the change of base formula, they do not want to see this whatsoever. They want to see this and taking it from there. On the back side, however, this is the nice section. They encourage you strongly to use it, so you might as well use it. And it is just a matter of saying the log of the physically larger number, so this number has a higher font, so it should go on the top, divided by the log of the smaller font, which is going to be 3. And then it's a matter of typing it in your calculator and getting that 1.465. You can do that for all of these. This would become log of 50 divided by log of 6, log of 15 divided by log 3, and typing that into your calculator. So as long as you remember that change of base formula, it's not a hard section. There's very little work. You do most of it on your calculator, but just kind of going from there. This next section is the solving section. We spent a lot of class time doing solving, so hopefully you feel pretty comfortable with this. I'll just kind of hit some basics on these problems, but not solve them all the way through because I want you guys to have plenty of practice. So the first one, you see that there is no logs going on at this time, but there is an exponent. So since there is no logs, I can go ahead and decide that I'm going to log both sides. And when I say log both sides, I mean literally write the word log on both sides. You could have also chosen to ln both sides. As long as you do it to both sides, it doesn't really matter whether you choose ln or log. It will work out either way. Once I have that set up, I can go ahead and say, let's pull that exponent out front. Again, doesn't matter which problem you're working with, pull that exponent out front. Let's say that I stick with the ln, I'm going to get x of ln of 10 equals ln of 17. I'm solving for x, so hopefully you would divide by ln of 10. Remember, this is something you would type into your calculator then. You can't do 17 divided by 10. Number 16 would be very similar, except you do not have this e variable alone yet. So you would want to go ahead and divide by 2 on both sides. Now that you have the e of x equals 10, this one does have an e value, so you don't want to really pick between log and ln. You definitely want to go ln here because this is an e. So you'd want to ln both sides, pull that variable out in front, and go from there. Number 17, same idea. You have an exponent just like number 15, except you do have this +3 tailing here on the end, and that does prove to be an inconvenience. So you might as well go ahead and get rid of that 3. You have 7 to the 2x equals 5. And then just like I was saying with problem 15 up above, you would want to go ahead and, pick ln or log. I tend to go with log unless it's an e. Log both sides, pull that exponent out front, and then go into division and so forth and so on. Number 20, same idea. You have this 10 proving to be an inconvenience and the 4. So if we go ahead and subtract 10 on both sides, you get 4 log of x equals -6. You still don't have the log by itself, so you want to go ahead and divide by 4 on both sides. You are welcome to turn this into a decimal. I, however, just kind of like to leave it in fraction form for now. This maybe simplify it a little bit. At this point, this is where it gets a little different than the last couple of problems we've done. This one already has a log in it. So I've seen a couple of people be like, oh, well, let me just log both sides. That's what we always do. However, this one already has a log. So if I try to log both sides, it's going to double log it, and then it just, it's mind-blowing. So instead, we kind of look at this and say, okay, it has a base 10. So according to our formulas on the first page that I said you definitely want to have written down in your test, we can rewrite this as 10, that's my base, to the opposite, so that's -3/2 power equals x. And then that is just something you can type into your calculator, 10 to the -3/2, boop, and you got your answer. Number 19, same idea as number 20. Get that ln by itself. So let's say I do all of my fancy dancy work, and I get my final answer to be the ln of 4x equals 17/5. Of course, that's not going to be a nice fraction. If you guys remember our ln conversion on the front, if you don't, you can kind of flip back to the front. Here's my ln conversion. It becomes an e to the power of x. So this is going to become e to the power of 17/5 equals 4x. And then it's just a matter of typing this into your calculator and then dividing it by 4. Number 18 is similar to problem 20. It already has the log by itself. There's nothing more you have to do. So if I rewrite that, I'm going to get that 7 to the 3rd power equals x plus 2. And then I'll just kind of leave you with that to kind of figure out where you go from there. But do take notice that that 7, that was my base. The 3 came across, and my x plus 2 went to the other side. Okay. So again, if you're really not familiar with those, quickly write those down at the top of the paper when you get your test, and you'll be fine. Just 2 more problems I'm going to go through. The first one is going to be number 22, because number 22 is one that when you set up everything, it says, you want to make a total. So total meaning that's going to be my A value is 10,000. Then it says that my initial investment, so that's going to be my p-value, was $1,000. My interest earned is going to be 12%. Be careful, I'm still seeing people mess up that conversion. So my rate is going to be 0.12. And then the problem here is they're asking you how long is it going to take, which means I don't know what t is. So when I set this up, I'm going to have 10,000 equals 1,000 e to the 0.12 t power. The problem that comes in here is my exponent is in the, or sorry, my variable is in the exponent. So when I solve all this and I get e by itself, I'm going to go ahead and have 10 equals e to the 0.112, or sorry, 0.12 t power. I need to get that exponent down. In order to solve for t, I have to get it down. It is an e, so I'm going to have to go ahead and ln both sides. Then that variable can go ahead and come down out front, divide both sides, and it should work out to look something along the lines of this. So you have the ln of e, you pull it down front, ln of e just becomes 1, and you ultimately have ln of 10 equals 0.12 t, and divide by 0.12 and get your final answer, which represents how long it will take. Again, this answer key that I'm showing you right now is on Canvas, so you can check it out later. Got 4 more minutes, I don't want to be too long. So the last two types of problems, a lot of people know how to do the math here. It's just kind of looking at the problem and kind of blanking. So I do give you this formula up here. This is the standard exponential growth formula. So if I go ahead and say, okay, here's my x and my y value, a lot of people forget that, surprisingly. Set up your equation, plug in your y, that's going to become 4 equals ab to the negative 2. Remember that negative 2 represents that it's really going to be on the denominator, so I have a over b squared. If I go ahead and solve that one for a, that means I have to multiply both sides by ab squared. And I ultimately get a 4b squared equals a. If I do it with the second problem, you have x and you have your y. You can go ahead and say that I have 64 equals ab squared. You want to get a by itself. Well, at this point, there are two different options that you can go from. If you look at my answer key on Canvas, the first method that I went with is once I got the first one solved for a. This one I chose not to make it negative, but it still works out fine. Yes, so I just divided by -2. So it would have been equivalent to having the 4b squared, because the -2 on the denominator means move it to the top. So I moved it to the top either way, same exact equation. But when I set up this second part, this whole 64ab, you could choose to go ahead and plug it into the a value. So you'll notice here I plugged it into the a value. I moved that -2 up top, so I have this 4b squared, which if you went with this original method, it would have been a lot quicker. You would have plugged right in. You know, it would have looked like 64 equals 4b squared times the original b squared. But over here, I just kind of went the long way around, and then it was just a matter of changing that b squared to a b to the 4th, solving for b, and going from there. If you don't like the substitution method, for the second problem, I did do it the other way, where I set up both equations. Here's equation 1, here's equation 2. I solved equation 1 for a, solved equation 2 for a. Once they are both equal to a, I go ahead and set them equal to each other. I cross multiply, that gives me 24b squared equals 12b to the 3rd. And then it's just a matter of kind of solving for one of your variables. So I divide it by the b squared over here. That caused these two pieces to cancel out. And over here, the b to the 3rd divided by b squared just gives me b. Divide, you get that 2. 2 goes back into either one of these, doesn't really matter, it'll give you the same answer. I tend to go with the one that's smaller. So I can do b squared in my head, that gives me 4. So 12 divided by 4. Now that I'm looking at this, I think that from, this is wrong. Go ahead and change this one. I'll just change this later. But it shouldn't be 12. I don't know where I got 12 from. But I'm plugging b into this formula. So I should get that 12. And then on the denominator, I get 2 squared, which gives me 4. And then 4 divided, or 12 divided by 4 should give me 3. Don't really know where I got that variable from. Gives me 3. And then my final answer should actually be a 3, 2 to the x power. So kind of a good self-check there. But yes, you do need to be very careful when you plug it back in. That when I plugged that 2 in, for some reason I made it a 12. I don't know if I saw the box and kind of thought that that was a 1. But you should have gotten b to be 12, a to be 3, and then don't forget to write your final equation down below. That's all the time I have right now. Hopefully that helps at least get you started on some of the problems. When you're working on this, make sure that you do check out that answer key. And then if you're working on your Brain Genie extra credit, then you can always look at how they explain different problems. Any questions that you have that weren't in this review packet probably won't be on the test, but you are more than welcome to ask me at any time about curiosity questions. But other than that, hopefully this helps a little bit and that you jumped around to the parts that you needed. Good luck.